NQA stands for Network Quality Analysis. It measures network performance and performs statistics collection about delay, jitter, and packet loss ratio on the network. In this network topology, we can measure the network performance and perform statistics collection about delay, jitter, and packet loss ratio between any two routers, between router 1 and router 2, or between router 1 and router 3, using NQA. NQA can real-time measure the performance of different protocols running on the network, such as HTTP connection delay, TCP/UDP connection delay, DNS resolution delay, FTP file transmission speed, and FTP connection delay. Use NQA to real-time measure the performance of the HTTP server. To test the HTTP connection delay, we can use NQA to test the TCP/UDP connections between any two routers, router 1 and router 3, or between router 1 and router 5. Any two routers in this network topology, we can measure the application performance between them using NQA. NQA requires two test ends: NQA client, on which the test is running and initiated, and NQA server, which is the destination of the test. NQA has different application scenarios. The first application scenario we have is performing network troubleshooting for network engineers who are in question of live networks and receive complaints from their customers that there is intermittent network disconnections, slow internet access, failure to access websites, slow file downloading. NQA is useful in this case to perform network troubleshooting and test the network connectivity between two routers, test the FTP, TCP, UDP connections. NQA is useful for learning about network services quality. We have different examples for NQA test instances, which will be performed in this video. First test instance we have here is ICMP test instance. We will test now NQA ICMP between router 1 and router 3. Log into R1 and go to the system view. Then we use command NQA test-instance, and then we name the NQA test administrator name as R1 or 3. Then we give the name of the NQA test instance. I name it as ICMP. Press enter, and next command inside the NQA test instance view, test type. I'll specify the test type as ICMP, and I'll specify the destination address of the test, IPv4, then the IPv4 address of the destination, which is R3. I'll choose the destination to be the Ethernet interface 000 of R3. At R3, display current configuration interface Ethernet 000, and this is the IP address, which is 10.23.23.2. Of course, R1, to be able to get this destination IP address, there must be routing between them. I have enabled OSPF on this network and over all these interfaces, so all routers at all interfaces can get each other. Then I will run the NQA test. The NQA test is run using command start now. Start now, which means the test will start immediately after I press enter. I can choose another options, start at a specified time or start at a delay time from now until the start of the test, I'll choose Start Now. Then press Enter. Quit. Now I'm going to check the results of the NQA test. Display NQA results. It shows all NQA defined on the router. And if I need to specify a specific test instance, I have to use test instance. Then I specify the administrator of an NQA test instance, which is R1, R3, and the test name of the instance is ICMP. This is the result of the test. It's completed successfully. There is no packet loss ratio. It's 0%, and this is the minimum, maximum, average completion time, and there is no drop, there is no loss of packets. Second example we have here is the ICMP Jitter test. We are going to test the variation of delay between two routers. I'll choose also router 1 and router 3 to test the ICMP jitter between them. Use command NQA test instance, and the test instance, the administrator test instance name is R1, R3, and the test instance name itself is ICMP Jitter. Then press Enter. Then we specify the type of the test using command test type, and the type of the test here is ICMP Jitter. Destination IPv4. Then I'll specify Start Now and quit. Then I'm going to display NQA results, test instance R1, R3, and ICMP Jitter. The completion status here is success, and we can see all the jitter test between R1 and R3. The left side is the send probe from R1, and the right side is the response probe from R3. We can see that there is no errors. We can see that packet disorder ratio is 0%, and also packet loss ratio is 0%. Next example we have is the HTTP test. We can use the NQA to test the HTTP connection delay on the network. In this example, I'll initiate the NQA test from R3 to test the HTTP connection delay to the HTTP server deployed here in the lab. The HTTP server here with the local address is 192.168.10.5, and the gateway address is 192.168.10.1 with the subnet mask 255.255.255.0, and the gateway address here is at router 1. This is the gateway IP address of the HTTP server, and the interface is defined inside the OSPF process. So R3 can get in its routing table the network of the HTTP server. The HTTP server is configured with this root path mac/home/desktop. At R3, we go to System View and configure the NQA HTTP test instance using command NQA test instance, and the administrator name is R3 and test instance name is HTTP. Test type is HTTP, destination address IPv4, and the address of the HTTP server is 192.168.10.5. The HTTP URL here is http://mac/home/desktop.com. And start now, quit, and display NQA results. We can see here that the completion of the test instance HTTP is success, and this is the RTT sum, minimum, maximum, and average between R3 and the HTTP server, and there is no loss packet ratio. HTTP error number is 0. TCP connection error number is 0. I can now stop the HTTP server and then back again, undo NQA test instance R3 HTTP and initiate it again, and start now to initiate the test. Display NQA results shows that completion is failed, and also the loss packet ratio is 100% because there is no connection with the HTTP server, and the HTTP server status is down from the HTTP server. Next example we have is the DNS test. In this example, I'll initiate the DNS resolution test between R3 and the DNS server deployed here in the lab. The DNS server basic config is 192.168.11.5 and its gateway is 192.168.11.1 and the subnet mask is 255.255.255.0. The DNS server is configured with this entry. The host name is mac/home/desktop.com and its IP address is 192.168.10.5. This is the IP address of the HTTP server and its host name. So the client, which is R3, is going to ask the DNS server to get IP address of host name of the HTTP server provided in the test instance from R3 side. I have to mention that the interface connected to the DNS server from R4 side is advertised in the OSPF process at R4. So routers can get the network of the DNS server. We can see here that the interface connected to the DNS server is defined in the OSPF process at R4. Going to the system mode of R3, I'll add command DNS resolve DNS server, and the DNS server IP address is 192.168.11.5. Next is to define the test instance using command NQA test-instance, and the administrator name is R3 and the test instance name is DNS. Inside the test instance view, I'm going to define the test type, which will be this time is DNS, destination address URL, which is the URL of the HTTP server, which will be mac/home/desktop.com. We have to make sure that this URL is properly defined at the DNS server, and DNS server IPv4 address 192.168.11.5. Start now, quit, and display NQA results. We can see here that the test result for the DNS is success. I have tested successfully the DNS resolution between router R3 as a source and the DNS server as the destination. Attempts number is 1 and receive response times is 1. There is no connection failure. The minimum, maximum, average completion time are these numbers, and the loss packet ratio is 0%. Last example we have is TCP test. We are going to test the TCP connection between two routers in the lab. In this example, we will select two routers R2 and R4 to run the NQA TCP connection test. R2 as the client or the source of the test, and R4 will be the destination. At interface Giga Ethernet 0/0/0. We will start the configuration by R4, which is the destination. We are going to configure the TCP protocol with a destination port number and destination interface. At the system view mode, we add command NQA server TCP connect destination IP address as the server 10.45.45.1 and the port number, the NQA TCP server port number. We will select 1000 as an example and press enter. Next is to select the source of the TCP connection and make the necessary configuration. At the system view mode, we add command NQA test instance R2 R4 and TCP as the test instance name. Press enter and we add command test type. This time is TCP, destination address IPv4, and the address specified at the destination server is 10.45.45.1 and the destination port 1000, which is specified at the destination NQA TCP server. We have to make sure that there is a routing from the source to the destination. We can receive the destination interface in the routing table as an OSPF route. Back again to the NQA test instance and add command start now to start the NQA TCP test. Now checking results, display NQA results and test instance, and the administrator instance name is R2 R4 and the test name instance is TCP. We received the completion as success, send operation times are 3, receive response times are 3, there is no drop, there is no error, and this is the destination IP address, minimum maximum completion time, loss ratio 0%, which means the TCP connection is normal. I have to mention that I can repeat the test. At the test, we already used command start now, which means, as we mentioned before, that the test will start immediately after we press enter. What if we need to repeat the test frequently? I can use command frequency inside the test instance view. There is an integer which is in seconds. This is the interval time between two continue same NQA test. If I specified, for example, 10, it means 10 seconds between last and the next TCP test. In the next video, we will see how to use the NQA for static routing to track a remote interface. Thank you for viewing this video. I hope it can add a good value to you.